Last week, I spoke with a bunch of people at a Zig Day organized in Milan, and many had questions about the Zig build system. So in this video, I will show you the basics of using the build system to create a package that others can depend on, and how to wire a dependency to your Zig project. The video will be divided in chapters, so feel free to skip ahead when looking at it again for reference, and also keep in mind that this video is for Zig 0.14, and as time passes, things like function names or other things might change. To get started, we need to understand two things about the Zig build system. One, the Zig build system is entirely implemented in userland, and all it does is invoke other Zig compiler subcommands with their CLI arguments set correctly. This means that as you go from a novice to an intermediate level user of the build system, you will be able to observe the CLI invocation of the Zig compiler and any other tool involved in a build pipeline, and use that as a powerful tool to validate assumptions and debug issues. Second, the code you write in your build.zig file will describe a build graph instead of performing the build immediately. This means that in the build script you will use the types and functions in std.build as a form of DSL in order to construct the build graph. This will require you to think in more abstract terms than you would otherwise, but in exchange you get automatic dependency tracking for each step in the build, which is what powers features like automatic parallelization of the build and caching. Next, we need to become familiar with the concept of a Zig package. You might be used to packages in other languages where you download a dependency and then directly import it, ideally using the same name in both locations. In Zig, things are a little bit more complicated. A Zig package can expose to consumers Zig modules, that's what you import, and we will talk more about them in a moment, static libraries, dynamic libraries, object files, full executables, and all the source files present in the package, be it Zig files, C, C++ files, and anything else like music, videos, or images, and even arbitrary files that get generated on demand by the build script of the package. In this video, we're going to create a package that exposes just a module and an executable, and then we'll see how to use it as a dependency in another Zig project. The first thing we need to do is create the basic package boilerplate. Normally, you would want to delegate this work to Zig init, but in this case, I'm going to write everything from scratch. I'm going to use a JSON parser package as the example, so I'm going to name the package myJSON. Zig already has a JSON parser in the standard library, and in fact, we're not going to implement the JSON parser at all, but using a concrete example will make it easier to contextualize the various things that you can do with the build system. A Zig package is defined by two files, a build.zig and a build.zig.zon. Let's start with the zon file. The zon file is the equivalent of package.json for JavaScript or pyproject.toml for Python, for example. It's a data structure that declares the package name and some other metadata, including your dependencies, but this package doesn't have any, so we're not even going to define the field. Later, we'll see how to add dependencies when we create a second project that will use this one as a dependency. In a zon file, you also have to list the files that make up your project. Any file not listed here will be deleted after the package is downloaded as a dependency, which is useful to exclude stuff like data files only used for tests. There's one last field that we need to add to our zon file, the fingerprint. Normally, Zig init would generate a valid one automatically, but we can still get the compiler to help us. First, we create an empty build.zig, then we run zig build. The error message will suggest a valid fingerprint that we can then go paste into our zon file. Again, this is clearly not very ergonomic, but that's because we decided not to use Zig init. I'm also aware that I'm not explaining what the fingerprint is used for, but that's a topic for a follow-up video, so for now, let's just paste the value and move on. If we run Zig build again, we are now greeted with a new error. This error might not seem very clear at first glance, but it's actually telling us fairly precisely what's wrong with our current file. As I told you earlier, the build system is userland code, which is why the error is in a file in the Zig standard library. That code is trying to load our build script, and it expects to find a declaration named build in it. Unfortunately, we left our file empty, which is why this code fails. Let's open our build.zig and fix that. While I type up the last bit of boilerplate, let me remind you that our build script doesn't execute the build directly, and instead, it just defines the build graph, which is why we need to add a function named build instead of main. The build graph is defined by mutating the std.build instance that we're given, which is why the build function can only return errors. The first thing we're going to do is define a module. In our example, the myJSON package wants to expose a function to parse a JSON string, so let's start by creating that. While not mandatory, it's not a bad idea to put your source code under a directory named src, source, and to name the entry point of a module root.zig. Keep in mind the consumers of your module will only be able to access the root file, so you need to make sure to re-export from it any declaration defined in other files that belong to the module. But in our case, we won't need to re-export anything because our parsing function will just print a to-do message. Now, back to our build script, we can define our module by calling b.addModule. The first argument we need to pass is a name for our module, which, keep in mind, is different from the name of the package as a whole. The second argument is a struct that defines all the various options that you can set on a module. It's highly recommended that you set up language server support for Zig in your editor, so that you can go to definition and see exactly what options are at your disposal. In our case, all we need to do is define the root source file. The type of this field is lazy path. Lazy paths are a key concept necessary to fully understand the build system, but for now it's enough to know that you can do b.path whenever you need to specify a source file. Lastly, since we're not yet using this module in the script, we need to discard the return value. This is where you need to internalize another key piece of knowledge. AddModule returns a pointer to our module, which we are now discarding, but the module itself still exists, and it also has been registered in the graph, meaning that even if we discard here the return value, consumers will still be able to access the module via its name. If we now save the file and run Zig build, we'll see that everything succeeds. Granted, the build script doesn't do much for us right now, but what we did up until now is already enough to expose a module to consumers of our package. Now, let's define an executable. Let's imagine that our JSON package wants to expose not only a parser, but also a CLI tool that offers features like auto-formatting or schema checking. The most direct way of implementing that would be to add a main function to our root.zig file. But even if this video is an introduction to Zig build system basics, I want to show you a slightly more advanced approach where we split the core business logic and the CLI tool into two separate modules. Here you can see that I'm creating a main.zig file, which will be the entry point for the executable. In this file, I'm defining the main function and I'm importing a module named JSON. Observant viewers might remember that earlier we defined in our build.zig a module with the same name, and they might conclude that this is how you wire imports in Zig. Unfortunately, they would be wrong, as we're going to see in a moment. Back in our build.zig, I'm going to stop discarding our module definition because we're about to use it. Next, I'm going to define the executable using b.addExecutable, and like before, go to definition helps me see what fields I need to define. Here, I can see that an executable needs a name, and scrolling down a bit, I can also see that it's possible to define directly a root file for the executable, but that it's being deprecated in favor of defining a module explicitly, so let's do that instead. Back to our build.zig, I give a name to our executable and start defining the root module. It's important that we have a clear picture about the modules that we're about to create. The executable needs to have a root module of its own. We could define it using b.addModule, but doing so would force us to give it a name and to expose it to our consumers. In this example, we do want to expose the parsing library as a module, but we don't want to expose to consumers the root module of our executable, and so instead of using b.addModule, we use b.createModule. If it's not clear already, the main difference between these two functions is that addModule also adds the module to the graph, while createModule does not. The build system tends to use the verbs add and create with that implication oftentimes. CreateModule supports the same options as addModule, so I'm going to start by setting the root source file to our main.zig. Once that's done, it's finally time to see how imports are wired in the Zig build system. One field that we didn't need earlier is imports. Imports is the list of modules available for importing to files part of this module. As you can see, we're specifying the name JSON again. This is because in the Zig build system, you have the ability to rename your imports, which is extremely useful in case of collisions, for example. Before we write the last bit of code, let's take a moment to understand what we are doing. Earlier, we used addModule to define a module for the JSON parser library, and we call that module JSON. The name that we gave it earlier is what consumers of our library will need to use to get a handle to that module. This is an API that we haven't used yet because we are accessing it through the pointer returned by addModule, but in the next section of the video, we'll have to use it. And just to be clear, we have to give a name to the module because a Zig package can declare more than one module, and consumers will need a way to specify which one they want to access. Anyway, after we created the JSON module, we created an executable which needs to have a root module. We could have put a main function in root.zig and reused the JSON module directly, but instead we decided to keep the business logic separate from the executable. In a realistic scenario, you would probably want to add dependencies to the executable that have nothing to do with the core parsing library. and keeping the two separate helps reducing complexity for your consumers. So for this reason, we created a second module, we made sure not to expose it to our consumers, and then we gave it the parsing library module as an import. Okay, now that this is all clear, let's add the remaining bits. Since we are defining an executable, we now have to worry about the target and the optimization level of the generated binary. If we leave this part unspecified, users won't be able to cross-compile the CLI tool nor create optimized release builds. The Zig build system has a standard way of defining target and optimization level flags. To learn more about how this part of the build system works, I invite you to read the build system guide present in the Learn section of the official Zig website. After we are done wiring these new variables, we have one last important thing to do. Tell the build system to install the executable in the output path when we run Zig build. At first glance, this might seem yet another piece of unnecessary explicitness, but in reality, not all executables defined in a build script should be installed unconditionally. Some might be executables that run exclusively as part of the build pipeline, while some others might make sense to install only when the user passes a special flag to Zig build. If we now run Zig build, we actually get a compile error because I forgot to use try in main.zig. Note that once the build script is correctly set up, ZLS is able to show us semantic errors. When I first edited this file, ZLS didn't show any error because I had not yet wired the JSON import. Okay, with this fixed now, Zig build succeeds and installs our executable in Zig out, and if we run it, we see the to-do message, so great. We have just created a package that defines a module and an executable. Let's see now how to use this package as a dependency in another Zig project. After recording the first part of this video, I uploaded my JSON to GitHub. This step is not mandatory, but in practice, Git repositories are the most common way in which people distribute Zig packages. To start, let's create a new project. I'm going to call it my app, and this time I'll let Zig init do all the work to set up the basic boilerplate. Next, we need to use Zig fetch to add my JSON as a dependency. Let's take a moment to see how this works. Zig fetch by default just downloads a dependency to your cache. But by passing the --save flag, we instruct it to also add the dependency to our zone file. The location of the package is referenced by a URL. In our case, we are interfacing with a Git repository over HTTP, so the protocol has to be Git plus HTTPS. After you're done specifying the repository, you can optionally specify a Git ref to target a specific commit, tag, or branch. When the ref you pass is not a commit, it will be resolved to a commit first, and then hard-coded in the zone file as a commit hash. If you don't specify any ref, Zig fetch defaults to the head commit of the default branch. After we run the command, let's check the changes it made to our zone file. The zone file generated by Zig init has a bunch of comments in it. It's not a bad idea to read them if you've never done it, but for now I'm just going to delete them to reduce clutter. You can see that under dependencies we now have my.json. The name my.json comes from the other zone file, but we have the ability to rename our dependencies by changing this line here. That said, we don't need to do it this time, so let's go to our build script and see how to wire everything. The generated build script also has a lot of useful comments that you can read, but that I'm going to delete for this video. As of version 0.14 of Zig, the Zig init template showcases a set of things that in my opinion is not optimal, so we're probably going to change it for version 0.15. More specifically, I'm referring to the definition of a static library. That's a feature present in Zig to enable C-ABI interoperability, and I suspect that some people might have mistaken it as the preferred way of sharing Zig code, while in reality, that would be modules. To fix this, I'm going to delete the static library definition and all related code, but before I do, check out xzmod.addImport. Previously, when we needed to add an import to the root module of our JSON executable, we did so by setting a field to the create module call, while here you can see an alternative method. Neither is preferable over the other, so choose which style works best for your use case. But just to give you some extra insight, consider how the addImport function call has the advantage that you can easily place it under branching and that you can also use it to define circular imports for situations where this kind of dependency topology is desirable. Okay, so we get rid of the static library, and then we are left with only the executable definition. To access our dependency, we can invoke b.dependency. The first argument is the dependency name as written in our zone file, and the second is a tuple of options. These options are the same CLI options that we defined in the my.json build script. In our case, if you remember, we define target and optimize, but if a dependency that you want to use defines some other flag that you can pass to the Zig build invocation, this is where you would specify that same flag. Calling b.dependency gives us back a type that roughly speaking represents the full myJSON Zig package. To get the JSON module from it, we can use myJSON.module, and now the module name we give it must match the name we specified in our call to add module from earlier. Now that we have a pointer to the module we want to use, we can add it as an import. I'm going to use add import like the script did originally, but I'm going to rename the module to JSON spelled differently just to show you that you can do it. Next, to test it out, let's go to main.zig and use our new import. Notice how we are required to use the new name we gave to the module. Now we can run Zig build and run the myapp executable. Actually, we can also do Zig build run because the build script defines a run step that builds and runs the executable, but I leave it as an exercise to the reader to learn how that works. And running the command fails because when I deleted all comments from the zone file earlier, I also deleted the fingerprint by mistake. Let me go fix that. Okay, success. We could stop here, but what I want to show you next instead is one neat trick when you are using a dependency that you control and that you want to develop alongside another project. More concretely, let's imagine that while we were developing my app, we found a bug or a missing feature in myJSON. In that case, what you would want to do is have a local checkout of myJSON, and then in the zone file of my app, you would change the dependency location to a local directory using .path. After you save the zone file, you can make changes to myJSON locally and then see how that impacts my app when you rebuild it. Once you're happy with your changes to myJSON, you can commit them and then go to my app and rerun Zig fetch again without any git ref to get the latest commit, with just one caveat. As of version 0.14, there's a bug in Zig fetch that causes it to forget that the field in your zone file needs to change from path to URL. One temporary workaround is to delete the entire dependency and then run Zig fetch after that. You can track issue number 21690 to know when this bug will be fixed. Congratulations! You now know how to do the two most basic things you can do with the Zig build system, create modules and executables, and add dependencies to your projects. Needless to say, this is but a tiny fraction of the things that you can do with the Zig build system. If you're looking for next steps, in my opinion, the best way to learn is to look at other projects and to ask help in a Zig community when you get stuck. On my GitHub account, which I will link in the description, you can find a good variety of examples of Zig projects, each with its own build script, and most of which also have dependencies. In particular, Zine has its own tiny galaxy of packages that import one another. If instead you want to explore more what can be done with C and C++ projects, then take a look at the All Your Code Base organization, also linked in the description, where you will find plenty of C projects packaged for Zig. And lastly, if you happen to stop by a Zig Day, that's also another pretty good opportunity to learn more about the Zig build system. Alternatively, feel free to leave a comment here on YouTube if you like this content or if you want to see some other Zig topic tackled with the same style. Alternatively, you can also join me on Twitch, where I live stream pretty often and where I'm also happy to answer questions from viewers. Link in the description for all this stuff. So with that being said, thank you and see you next time.